Okay, so what I want you to do, I want you to do all these questions now. All of them, be careful, all of them are level 1 problems. So you shouldn't face any challenges at all. This is miscellaneous exercises بلنداد و بیفتر for chapter 1. And we have studied everything you need to solve these 4 problems. I mean, if you are good, in principle, these 4 problems containing how many sections? 11 sections shouldn't take more than 15 minutes. Yeah, everyone please do it, okay? This is a good opportunity for the people who are a little bit behind. This starts from all the things we have learned. So you can, I will review them again when I am solving here. So I give you 15 minutes. At 9, I will start solving the problems. Okay, so the people who actually don't know how to solve those problems, please listen to me. I explain them on the board. But if you have already solved those problems, you don't need to listen to me. You can start doing these 2 problems, okay? Yes? So it's a multiple choice question. Some informations are provided for you and something is wanted. So you're supposed to find that. But the rest of you that you have problems here, please listen to me so that I can explain. I think I made a mistake in writing one of these, didn't I? Okay, I have to switch back to this view. Okay, so now I think I wrote something wrong in this one. When we reach there, we can check. Okay. So here, 5x plus 10, yes, is what? If I want to factor it, this is just factorization. They have expressed it in a little bit strange language. They can simply ask you to factorize. Okay, but they have asked you to pull out the factor, the biggest possible factor. Okay, so what we do, I told you this is very simple. You need to write this as a product so that when you do this multiplication, the answer becomes this. So somehow you can imagine this is a reverse engineering point of view. Okay, so I would write 5 times x plus 2. I don't want to explain more because this is so simple. Why this is correct? Because first of all, it's a product. Factorization means product. Write the expression as a product, and then when you multiply this back, it gives you the same answer. And this is the biggest factor you can pull out. Yes? So that's the answer. And you don't need to explain. When you see factorization, just write this like that. And if you have questions, everyone, do you understand me? The people who have problems. Here, what should I factor out? A. I pull it out, then I ask myself, what should I put as a question mark here? What should I put as a question mark here? Of course, the sign between them is plus. The first question mark should be something that when I multiply A back, it gives me 28. Of course, it should be 20. The second question mark should be something that when I multiply A by that, it gives me A squared. Of course, that is also A. But that's the factorization of this. So the answer to this is extremely simple. But here, I hope that you remember this is which rule? This is the squaring rule. Okay? The common mistake is people write this one to power 2 plus this one to power 2. But I hope that you remember that I told you several times that this is not correct. The correct one is, if you are not very quick, you can just write it in 2 steps. If you can do it in your head, it is much better to do it in that way. So let me do it in 2 steps for this one. I would say the first one is squared. Of course, you have the formula sheet in front of you, but try to memorize them. It's extremely important. After understanding them, you have to have them in your memory. Okay, and this is plus, so that's the plus version. 2 times the first one times the second one plus the second one, the squared. This is the Math 2C lesson. The rest of it is Math 1C. So if I ask you what is 9 to power 2, the answer is 81. You have to do this product, okay? So 2 times 3 is 6. Because if I multiply 2 by 9, then I have to know what it becomes 18, and 18 times 3, it becomes 54. But might be it is easier for you to multiply by 2 by 3 first, 6, 6 times 9, in principle, you should know that this is 54, and then I have x, and this one is 9x squared. So this is the answer that the problem expects you to write down. So you don't need to write this middle part. It is better not to write the middle part, but anyway. Any questions? This one is also the same problem, but this is the minus version. Okay, so it becomes the first one squared minus 2 times the first one, yes, times the second one. And then plus the second one squared. Again, you don't have to write this middle step. If you get confused, write it down. Okay, the first one squared is just simply 25z squared. And 2 times 5 is 10. 10 times 11 is 110. I have a minus sign, so it becomes minus 110. And then I also have a z. Finally, 11 to power 2. Either you should do it by hand, or probably the calculator will be provided. 11 to power 2, I have it in my memory after all long these years that I have been teaching, so I have them in my memory, so that's the answer. I think I wrote this question wrong, yes? It should be 4a, I think, not 4b. Let me double check. Yes, that is 4b minus, no, this is 4, so I completely messed up, I think. What was that? It is 4b, it's 4b minus 11a. I don't know why I wrote it like this. Minus 11a, and this is 4b. This is also a. Yeah, sorry. Okay, so that is the correct question from the book. But hopefully you remember the pattern here. What pattern is this? This is conjugate pattern, because I have two expressions involved. Once added, once subtracted, and I want to multiply them. So the answer becomes the first one squared minus, always minus, the second one squared. And then you have to go one step further. 4b to the power of 2 is 16b squared. And 11 to power 2, as we had here, is 121. A to power 2 is a squared. Yes, as simple as that. Any questions? Are you following? Yes? Okay. Now here, this is factorization again. This one is Math 1C, which is very similar to the first problem, but these two are for Math 2C. We didn't know that in Math 1C. So here, if I ask you to factorize, if you factor A out, okay, that is not completely wrong. So you will write 56a squared 42, okay? Why is this true? Is it a factorization? Yes, because if I ask you what this is, you would say this is the product between these two expressions. So it is in a product form. So far, so good. Is it correct? Yes, because if I multiply this back, I will get that answer. But this, you will lose some points because that's not the complete factorization. Complete factorization means pull as much as possible. Pull out as much as possible you can. So this is why you shouldn't write this. If there are 2 points, might be you get only 1 point for writing that. But what is the correct one? I also need to factor something out from numbers. Do you see which number is that? Because you know that this can come in the exam. In that part, the calculator is not allowed because you are expected to know these numbers. So 42 is what? 6 times 7. And 56 is 8 times 7. So I have to pull out 7 as well. Yes? So I pull out 7 and 8. And then I ask myself, I have an addition sign here, a plus sign. I need to ask myself, what should I put these to? So that when I multiply this back, I will get that answer. What is the first question mark? Is 56 divided by 7 is 8. And then you have 8. Is that right? Yes, because if I multiply this back, 7 times 8 is 56. 8 times, oh, sorry, I made a mistake. 8 times a squared, because 8 times a squared should be a cubed. And then the second one is what? 6. So I made, again, a mistake, you know. What is the mistake here? Yes? You can pull out more. Of course, it is not a mistake if you realize what could I factor immediately out? 14. Okay, so this is divisible by 14. This is divisible by 14, but I couldn't see it even myself at that point. So it doesn't mean it is wrong. You can continue one more step. If you realize that you can pull 14 out, you can do it in one step. But as I also missed myself, I pulled 7 out, then I realized, oh, there is another factor of 2 that I can still pull out. So don't stop. Pull another factor of 2 out. So if I pull a factor of 2 out, this 7 will be multiplied by 2, which becomes 14, and then I have a. And then when I pulled 2 out, from here, 4a squared is left. From here, 3 is left. So if you stop here, even though it was very close to be completely correct, but it is not complete because I could also factor something out. When they say factorize, it always means that you have to pull out as much as possible. Any questions there? Okay. Now this is a math 1C lesson. We did this before even. But now these are new ones. So what is the answer to this one? This you have to recognize the pattern. This pattern is comparable to a squaring pattern. Is it? How should I check it? First of all, if it is going to be a squaring pattern, which version is that? The minus sign version, because I see -1. Okay, are there 2 complete squares? Yes. This 121 should be famous for you now. Okay? So 121 is the complete square, is a complete square. It's 11 to power 2. Y is also a complete square. So I would say that I will write y at 11 here, but it is not guaranteed yet to be true. You have to always check the middle one is correct. The first one squared is correct. 2 times the first one times the second one, which is 22y. So that is also correct. The second one to power 2, that's also correct. So the only thing that you have to do in this problem to recognize the pattern and reverse engineer that. And that's the answer. Yes? Questions here? The next one. The next one is a good problem because I have already told you that this one that you learned in Math 1C has priority over this method and conjugate method. So you see that I can pull 9 out. So this is always the first step. So pull 9 out. Then from here, a squared is left minus this one is what? 4. But here do not stop, because then you recognize the conjugate pattern here. So you write a, you open 2 pairs of brackets, one with plus sign in the middle, one with negative sign in the middle. And then, of course, you write a plus 2a minus 2. So that is the correct answer. So some of you might start the conjugating rule first. So you say that, okay, this is the difference of two complete squares. So that is also conjugate rule. I agree with you. So then what do? You will put two pairs of brackets, one with plus, one with minus. And then you take square root of this one in your head, it becomes 3a. You take square root of this one, it becomes 6. You also write this. If I tell you, is this equal to this? 100% yes, because conjugate rule is always true. But it doesn't mean this is a complete factorization. So if you do it here, it means that you understood the lesson, but they have intentionally designed the numbers in this way that you fall into this trap. They want to test if you have a deeper understanding. So you see, of course, you can continue even in this way. You can pull a 3 out from the first one. You can pull a 3 out from the second one. And then, of course, 3 times 3 is 9. And the answer that you get is actually squares with the answer that we got before. But don't do that. From my experience, it is better not to do it because sometimes it is hard to see it in this way and sometimes impossible. So try to learn it in this way. If it is possible to factor something out from all the terms, first do it. In other words, the one you learned, the method that you learned in Math 1C has priority over these two methods that you learned in this course. After you did that, then think, is there any Math 2C method available for the rest? If it is, do it. Otherwise, you have to stop there. Any questions? Okay, so I don't know. I haven't made any mistake in writing this. Hopefully the book hasn't have any typos there, okay? So if you want to do this, what I'm supposed to do? What I'm supposed to do? It's a little bit a strange way because 9 minus 1 is what? It's just simply 8. Okay, so this one, I don't have any problems with it because it's a pair of brackets, but behind that there is nothing. So I can just simply open it up. But here, I would prefer to put this minus sign, multiply a inside, so it becomes what? 24x plus 8. And then remove the second pair of brackets. But the only thing that you have to be careful about is this nasty minus sign. So this minus sign is not just only for the first one, which is a common mistake. It is also for the second one, and it is also for the others if there are some other terms as well. In this case, we have only 2 terms. So I copy and paste the first part, and then I multiply this minus sign in, so it becomes minus 24x, but also multiply this minus sign here, this minus 8. And then I have 2x minus 24x, which is minus 22x's, and minus 5 minus 8 is minus 13. So that's the correct answer. Let me check the faucet because usually in the books they don't write something like this because everyone knows that 9 minus 1 should be 8. But let me see, which question is that? Question number 4, part A. Question number 4, part A. Minus 22x minus 3. That's correct. So that was their intention. Really, they mean that. Okay, but this one is more common. This is a very common exercise. So you see, this was a level 2 problem in Math 1C, but now they consider it level 1 problem in Math 2C. So what I'm supposed to do here, I can multiply this 3x in, so this becomes 3x squared minus 12x. Here, I have 3 numbers involved. If I want to multiply 3 numbers, one common mistake I have seen a student makes here is that they multiply 5 here and there. No, you have only one 5. You have to decide if you want to multiply it here or multiply it there. But my recommendation for you is that don't be in a hurry. Just write minus 5 here. open a bigger pair of brackets with more space within, and then multiply this as if this is your only problem. So multiply 3x there, so it becomes 3x squared minus 3x, and then 2x minus 2. Okay, so in these problems, you shouldn't be in a hurry. I mean, so I still copy and paste my minus 5 here because I see that there are two terms involved that I can simplify them more. So it becomes 3x squared minus x minus 2. Yes? And then I multiply this minus 5, and then I am again careful that this minus 5 with its minus goes for here, for there, and for there. So the answer becomes 3x squared minus 12x minus 15x squared plus 5x, because minus times minus is positive 5x, and minus 5 times minus 2 is plus 10. Yes? Okay, and then don't stop here because we have to simplify if possible. 3x squared minus 15x squared is minus 12x squared. And then minus 12x plus 5x is minus 7x. And then 10 is a law. That is the answer that you're supposed to get. I mean, some of you, I don't know how many of you could solve this and find this answer exactly. This is extremely important. Go back to this list. If your answer is not exactly the answer that I got, mark it. Mark it and review it at home. Because that's the only way that you can learn. Redo it, you know. I don't know if your answer to this question, let me also check my answer. This is a habit. When you study math books, you have to have the habit of putting the faucet in front of you to check that if you are doing it right. So what is this question? It's question 4 part B. Question 4 part B, the answer is minus 12x squared minus 7x plus 10. That's correct. So yes, it is very important to put the faucet next to you. And then finally this question. So this question, actually this is Math 1C question. It has nothing to do with Math 3C. The only mistake that people make is that sometimes they want to simplify 3 with 12, or they want to simplify this x with this x, or this x with that x. This is not possible. You can only simplify common factors, okay, not summands. So what you do first, you try to factorize the numerator and denominator as much as possible. Of course, you know that the denominator cannot be factorized more, but you can immediately see that I can pull 4 and x out. So what is left from the first one is xy, because if I multiply it back, I will get this answer. And then the next one is plus 3. Okay, but can I simplify something now here? Yes, because x plus 3 as a whole and x plus 3 as a whole are factors. So then these can be simplified. When I say simplified, it means 1 is left. So 4x times 1 is just 4x. The denominator is 1, but nobody writes 4x over 1 because we can simply write 4x. That's the correct answer to this problem. Okay? Any questions? Okay. Now I want to solve the harder problems for the people who are doing the hard ones, but I want to assign some exercises for the others. Okay? So let me show it here for you. Sometimes it doesn't. Anyway, so I want you to solve these problems. 8 and yes, start from 7, 8, and 9. Okay? These are very simple equations. The topic has changed. Some of them are quadratic equations, some of them are root equations. Yes, but still they are level 1 problems. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it shouldn't take more than 15 minutes for you to solve this problem as well. Okay? So please do that. Okay, so now those people who are solving the hard ones, could you solve it? Yes. Yes? So So sorry, I have to, okay, I have this problem here. Let me see if I can find it on my laptop. Which problem is that? Do you remember what was? Okay, 11. So this was one problem. This is given that we know that a squared plus b squared is 117. We also know that the product is 54. And then we want to know what a plus b over a minus b is. Usually, I don't know, might be they are careless and they have designed these numbers that you can somehow guess the numbers. I don't know what was your method, but I don't want you to rely on guessing, because guessing two numbers whose product is 54 and the sum of the squares is 117 is not that easy. Even if it is easy, that is because they designed the question in a bad way. They can really choose two numbers for you so that you cannot really guess at all. It's not hard for me. I can do it in a matter of seconds, you know. I can imagine two very weird numbers in my head that you cannot even imagine to guess. Then I construct these things, then I ask you the same question. My point is that don't rely on guessing the numbers. I don't know. Could you guess any number? So what was your method? I want to hear from you. Did you solve it?
Yeah.
Yes, you can explain.
I wrote like.
You started by guessing or not?
No.
Okay, that's good. So tell me, what did you do?
I wrote since I know the sum and the product, so I wrote a squared plus b squared plus 2ab is equal to a plus b to the power of 2.
Okay, exactly.
And from there, I put the numbers in and it just solved it.
Okay, so let us see what have you got. So you are doing it very good. This will solve the problem for the numerator, but you have to do something similar to find the denominator. Yeah. Thank you very much. So what he is saying is that you know a squared plus b squared. So the people who are solving this level problems and still believe that they have to write it, yes, I don't know how to say it now. Don't to fall into this trap. So a squared plus b squared is not the same as a plus b to the power of 2. But we know that if I have 2ab here, then I am done. So might be this motivates you to multiply this by 2, which becomes not very hard to guess, 108. I multiply 54 by 2. But now what do? I add this and that side by side. So it becomes a squared plus b squared plus 2ab is equal to what? 117 and 108. By the way, it's not very hard. What is that? 225. You add them up. 117 added to 108. But then this becomes a pattern. Yes, do you agree? What pattern is that? A plus b to the power of 2 is 225. Okay, I see that this question is not, okay, might be it's correct. Let us see. But then, what is a plus b? You can also have your calculator. If you put 225 in the calculator, take the square root, it gives you 15. Okay, but what is, that's why I'm saying I'm not sure if they have designed the question, if the author was aware of doing it in this way. Because 15 is not the only number. There are two numbers whose square. Be careful. A square root of 225 is not plus minus 15. It's always 15. But this is the different problem. I am trying to see what a plus b is. I know a plus b to the power of 2 is 225. So there are two options for a plus b. Either what? Either positive or negative. Okay. So let us see what happens now. We have to consider both of them because there is nothing given in the problem to me so that I can take one of them off. Of course, I know that the product is positive. What does it mean? It means either both of them are positive or both of them are negative, but still I don't know. If both of them are positive, of course I end up with a positive answer for the sum, and if both of them are negative, I will end up with a negative. I think that is a mistake in the question. Let us see how it goes. because it is not completely clear which one I have to choose. They have to mention this. Otherwise, you have to consider both scenarios. Okay, but this somehow solves my problem for the numerator. I have it, two numbers. But I hope that everyone now agrees a similar argument will give rise to knowing A minus B, yes? Okay, so what is the idea? This time, instead of adding them side by side, I subtract them side by side. So it becomes A squared plus B squared minus 2AB is equal to what? Is equal to 117 minus 108. What is the number? Is that 9? Yes. And then what happens is A minus B to power 2, because that's a pattern with the minus sign, is equal to 9. So what do I have? What do I have for A and B? A minus B. Again, A minus B is two possible numbers. What are they? Plus or minus 3. Yes? Okay, so that's a little bit big problem in front of us. Because how many possibilities there are? 4. Because plus and plus, okay, minus and so and plus, and then plus and minus, minus and minus.
Isn't that just 3 possibilities? Because it doesn't matter which one of them is a negative. It will turn out to be the same.
So that I exactly don't know. I have to check it out, you know, because that question mark is A plus B over A minus B. Is it possible to have A plus B 15 and A minus B 3? Is it possible? I mean, do you think that this is possible, that A plus B is 15 and A minus B is 3? Yes, because for example, add them up, 2A becomes 18, A is 9. If A is 9, B is 6. So it is possible. So one answer is 15 divided by 3, which is 5. Is it in the options? Yes, it is option B. But this is not the only one. So is it possible to have A plus B minus 15, A minus B 3? Is it still possible? Let us check. A plus B minus 15, A minus B 3. Is it possible? Yes, when I add them up, 2A becomes minus 12, so A becomes minus 6. Yes? And then what happens for B? If A is minus 6, B is minus 9. Is it also possible? Yes. Because it's still the product. So that's also possible. So one possible answer is minus 5 as well. But let us do it the other way around. The other way around, is it also possible? A plus B over A minus B. So A plus B is what? This time I take it as minus 15. This time I take it as plus 3. But is it possible to have this scenario? Which one I have to consider? No, this one should be, this time, this one, yes. Is it possible to have that? We don't care, because even if it is possible, I get back those two answers. What I'm trying to say is that they have been careless in designing this math question, because math questions shouldn't be ambiguous at all. Yes? So you see, both of these cases are really possible, because one option is A plus B is equal to 15, A minus B is equal to 3, which is possible because if I solve this system, what do I get? I will get A to be 9 and B equals to 6. And then I solve this one, I get these two answers. In one of the scenarios, A plus B is 15, A minus B is 3, and in the other scenario, A minus B is 3, A plus B is 15. Yes, so both of the answers are correct. So that is probably not a very good question. It's a good question, but it was ambiguous. They should have mentioned that A and B are positive or something like that. Okay, let us go to the next problem. So what was the next problem? Could you solve that one as well? Yes, very good. So you see, you have made a lot of progress. If you could cope with these problems, it means that your math knowledge is actually increasing. Okay, so what is the other question? The other question is a squared plus 1 over a squared is equal to 10. But what they want you to answer is what is this number? Yes? So what should we do? Yes?
I squared the left one, and then
Both sides.
No, yes, both.
So yes, that is possible. When you say this number is 10, everyone should agree that this number to power 2 is equal to this number to power 2, because when you say they are equal, the square of this one should also be equal to the square of that one. The square of this one is extremely simple, it's just 100. But the square of this one is a squaring pattern. So it becomes the first one squared, which is a to the 4th, plus 2 times the first one times the second one. And then plus the second one to power 2. Yes? Okay, but then the interesting thing of this combination is that a squared and 1 over a squared simplify, and it becomes 2. So this becomes a squared, a to the 4th, plus 1 over a to the 4th, plus 2 is equal to 100. But you are not looking for a, you are looking for this combination. This combination is the question mark. But the question mark is now what? This is something so that when 2 is added to it, the answer is 100. So the question mark is what? The question mark is 98. Is the 98 there? Yes. So that was a little bit better question. Okay. Okay, so what we are dealing here now. So the people who are working on these problems. Okay, so any questions here? Could you solve it or not? Which one? We don't have time to solve all of them. Let us pick some of them. Okay, let us answer them just orally. So what is the answer to the first question? Solve the following equations and let us say this is given to you. What is the answer? Yes? Don't say undefined. You need to write this equation does not have any roots. Yes, but why? Because x squared cannot be a negative number. So there is no way that I can find a real number whose squared is negative. So that's it. It doesn't mean the question is wrong. If this is given, the answer to this is there are no solutions. What about the second one? The same story. What about the third one? No. No. Still there are no solutions. Yes, why is that? Because a squared plus 900 is supposed to be 0. If I move 900 to the other side, it becomes what? Minus 900. So that's the same problem. A squared is minus 900 is not possible. So all these equations that you saw there, first and second and the third, they are not wrong, but the answer to the problem for these questions is that there are no real roots. What about the last one? 2b squared plus, what is that? Plus 75 is equal to 25. So what do you do? First, you move 75 to the left. So it becomes minus 50. Why? 25 minus 75. And then you divide by 2, you will face the same problem. Yes? No solutions. So this exercise is training you about that sometimes quadratic equations doesn't have any, they don't have any roots. Okay, so now here, the next problem. Solve the following equations in any way that you like, because there are three methods, yes? ABC formula, PQ formula, or the squaring, completing the square method. Completing the square method sometimes is good for you if you like it, but I prefer to use the PQ or ABC formula. PQ formula is very suitable for this problem. Why? Because this is 1 and the second term is even. Whenever this is 1 and the second one is even, might be, and then you have it in the formula sheet, you have both of them, so might be it is not hard for you to just read it from the formula sheet and use it. So let me solve it here using PQ formula this time. It's better to have these alternatives. Okay, so what is the question? The question is x squared plus 2x minus 35 equals to 0. So P in this problem is 2, Q in this problem is minus 35. The discriminant in the PQ form is this square root. So P divided by 2 is 1. 1 to power 2 is just simply 1, minus Q is minus 35. So it becomes 36 and it is 6. And the formula in PQ formula, this is very simple, plus or minus, minus P over 2 plus or minus a square root of D. Okay, P is this number, divided by 2 is 1, there is a minus sign, so it becomes minus 1, plus or minus, this is my bad, D is just this one. When the problem is so simple, I cannot concentrate that much anyway. So this answer becomes 1 minus 35, it's just 36. Be careful. D is what is below the square root sign. So I put it here, it becomes the square root of 36, and it becomes minus 1 plus or minus 6. Then I have two options. Either I choose the positive sign, minus 1 plus 6 is 5, or I choose the negative sign, minus 1 minus 6 is minus 7. So these are the answers that you are supposed to provide for this problem. Okay, I just solved one more. Let us solve the last one in part 9. It's a root equation. We are supposed to solve x minus 3 equals to 2x, and I don't know why they have put this pair of brackets around. It is not needed at all. So let us solve that one. So x minus 3 is equal to 2x, 2 square root of x. You know that this is a root equation because your unknown x is below a third sign. So what was the strategy to tackle the problem? To square to get rid of. The strategy is to get rid of the third sign by raising to an appropriate power. But what was the problem? This is a very simple one. This is why it's E question, because you don't need to modify the question. You can just immediately start raising to power 2. The hard ones are the ones that raising to power 2 immediately does not work. Then you have to rearrange them and then raise to power 2. Okay? But anyway, this is a very simple one. So I would write x minus 3 squared, and then the right hand side is squared. This one is the squaring pattern. The first one squared, minus 2 times the first one times the second one. The second one squared. What happens to the right side? I have two numbers multiplied, squared. For multiplication, this rule works, that this one squared multiplied by this one squared. This one squared is 4, this one squared is x. And then, because of this x squared, you know that this is a quadratic equation, so you move this to the other side. So it becomes x squared minus 10x plus 9. Again, I prefer to use PQ formula here. Why? Because this is not only 1, the second one is also even. Whenever this happens, PQ formula is a very suitable one. So what we do, I will calculate D. So that was my mistake there. So what was P here? P is minus 10. What is Q here? Q is 9. Yes? Okay, so D has the formula P over 2 to the power of 2 minus Q. P is minus 10 divided by 2 minus 5 to the power of 2. And minus Q is minus 9. So it becomes 25 minus 9 is 16. Yes? And then I have the formula X equals to minus P over 2 plus or minus the square root of D. P divided by 2 is minus 5, but there is another minus sign here, so it becomes positive 5 plus or minus the square root of 16. But the square root of 16 is 4. So then I have two answers. 5 plus 4, 9. And then 5 minus 4 is 1. But the only thing that you have to be careful, don't fall to this trap that think that these answers are acceptable, because that's a root equation. You have to check, might be some of them, one of them or two of them are false roots. So how should I check that? So I go to them, checking x equals to 9 to see if it works. There are two sides of this equation. You can calculate them separately. Instead of x, I put 9. The left side becomes 6. Instead of x, I put 9. 2 times 3 is 6. They are equal. So this I accept. Yes? But x equals to 1. This is a very good question because it was not algebraically complicated, but it captures all the features that you are supposed to be careful about. Yes? Because you see the second one does not work. X equals to 1, I put it on the left side. It becomes 1 minus 3 is minus 2, and I put it on the right side. It is 2 square root of 1 is 2 times 1 is 2. They are not equal. So this is a false root. It's a good, very good question, I think, because it teaches you everything that you have to be careful without complications. Okay. Any questions? Okay, I will just check the attendance and then we can stop here. Thank you.